Hello everyone. Today we are going to discuss about the Kubernetes architecture. Before discussing the Kubernetes architecture, we need to understand one concept. Like in, I would say, in Kubernetes, the smallest unit is pod. Okay? So the smallest thing in Kubernetes which you are good to create is called as pod. Okay? And what we are going to have inside the pod, we are going to have container. Okay, we already have very detailed discussion. What is the container? What is the exact meaning of container? How it is going to be created and other things. And container created by if this is my pod. Okay, so in this pod, I'm good to have container. Okay, so the next question comes: do we to only have one container inside the pod? The answer is no. In a single pod, we are to have n number of containers according to our requirement. So, which means in a single pod, if I want to create multiple containers, I am good to create it. Although we are going to have a very detailed discussion, like when we need to have the multiple containers inside the pod, what it is called, what is the purpose of it, and all. But for now, I want to focus only one thing. The smallest unit in Kubernetes we have is called as pod. And this pod, I would say, this pod can have single container or it can have multiple containers. Okay, so let's continue our discussion for the Kubernetes architecture. The whole architecture, I would say, of the Kubernetes is divided into three parts. One, it would be called from the user end. The second one, it would be called as master plane, or it is called as control plane. And finally, we are going to have worker. Okay, so when it is, we have the three component. One, it is called from the user end. This is the first. The second one, it is called as master node or control plane. This is the second one. And the third one, which we have called as worker. Okay, so let's draw a quick diagram to understand these things in detail. So I would say from the user end, the user request can be sent through kubectl. Kubectl is a command. In the next video, we are going to have a very detailed discussion how we are going to install the kubectl in our virtual machine and the other configuration. Apart from kubectl, we have one more option which is called as graphical user interface. So using kubectl or graphical user interface, we are good to send our request. So what is the exact meaning of sending this request? I would say I want to create a pod. So what I'm going to do through kubectl or through graphical user interface, I'm going to send a request. I want to delete the pod which I have created. Again, the request will be sent from kubectl or graphical user interface to the master. So as I mentioned, we have one master node, and the third component which we have is worker node. We are good to have multiple worker nodes according to our configuration. But in this example, I'm creating only, okay, which change the color. Okay. So this kubectl or graphical user interface is going to send the request. So where this request is going to be sent, in our master node, we have one component which is called as API server. Okay, so the kubectl or graphical user interface is going to interact to our API server. Okay, so here comes very interesting thing which we need to understand. What is API server? The question is, the API server. So the first functionality of the API server is to work as a tree point, which means whatever the request we are going to get from the kubectl or graphical user interface, it is going to interact to our API server. Okay, that's why it is called as an entry point. The second functionality of the API server is for the authentication authorization. So what is the exact meaning of it? I would say we have two users. This user is user A and we have another user called user B. So user A does not have the access to our Kubernetes cluster. It does not have, and user B has the access to our Kubernetes cluster. Okay, so when user A is going to send the request from kubectl to API server, it will be rejected because it does not have access to our Kubernetes server. So the rejection of the request, it would be done through the API server. And when user B is going to initiate the request, it would be accepted because it has access to our Kubernetes server. So who is going to provide the authentication or the authorization? It would be done by our API server. We are going to have a dedicated session to manage the authentication and the authorization in our Kubernetes cluster. Okay. The next task of API server is validate the YAML configuration. I'll say if user B is going to send a request to create a pod. Okay, and for the creation of pod, it has written a YAML file, and this YAML file has some error. Okay, so when user is going to send a request using kubectl, the request will be sent to the API server, and then API server will say there is some error inside your YAML file. Please check it and send it again. So this is one of the purpose of our API server. You have noticed I have mentioned double arrow in the API server because once we are going to send a request, it will be input, and then the API server is going to process it, and then finally it is going to give output. If we are sending a request to create a pod, if everything is good, it will keep like, okay, your pod has been created. In the second example, we have written a YAML file to create our pod, and if there is any error, it will give the error is present in your YAML file. That's why I have mentioned like this. Or the fourth purpose of API server is to connect to other components. The components in master node. Here comes very interesting question. What are the other components we have present in our master node? Okay. So the other component in our master node is controller. Okay. It is called as and is connected to our API server. So we need to understand what is the purpose of control. Okay. Second component which we have is control. Okay. So let me scroll to top. See, in our kubectl, what we are going to send a request, I would say we are going to send a request to create our pod. Okay. So the pod request will be sent to whom? To our API server. The API server, as I have mentioned, will check our authentication, will check our YAML file is validate or not. Then it has to create a pod. Okay. So the controller has n number of controllers present inside the controller, which means, let's take an example. Okay. We have one manager. Okay. We have n number of team leads who are reporting to this manager. One, it would be database team lead. The another one, it would be, I would say, networking team lead. The third one, it would be cloud team lead. The fourth one, it would be Azure DevOps team lead. So currently, who is the point of contact? The manager is our point of contact. And how many team leads are present? We have around 14. So if manager is getting any request which is related to database task, then it is going to assign to whom? It is going to assign to our database team. In the same way, if manager is going to receive a request for DevOps purpose, then it is going to assign which team lead? To our Azure DevOps team lead. So the same way, we have our API server. API server is a manager. Okay. And it has received a request to create a pod. So it is going to send a request to controller. And in controller, we have one thing called as pod controller. Okay. Then this pod controller will take the responsibility of creation of the pod. Okay. If you are going to send any other request, I would say for creation of deployment, it is one of the component which we are going to discuss. Again, it will follow the same path. It will interact with our API server. API server will check the authentication. API server will check the authentication and the YAML configuration. If everything looks good, it is going to send a request to our controller. And then in this case, controller will not assign the pod controller. It is going to assign the deployment. Okay. So in general, we are good to say controller is who? Means once we are going to send a request for creation of our pod, it will go to our API server and then controller will assign the pod controller. Okay. If you are going to send a request for deployment, again, it will come to the controller and the deployment controller will be assigned. Same way for service, for our storage task, for anything like whatever the request we are going to send to our API server, the controller is going to assign a dedicated controller to complete the work. Okay. So finally, after assignment of the controller, it is going to send the request to our API server. So the API server is going to interact to our another component which is called as scheduler. Okay. And what is the exact meaning of scheduler? Scheduler means we have scheduler means we have the pod controller, we have the pod, we are going to send a request, we have the pod controller. Scheduler is going to schedule means creation of our pod in one of the worker node. This is my worker node 1 and this is my worker node 2. Okay, so scheduler is going to create the pod in one of the worker node. So how it is going to create the worker node? Third component is schedule. It works on the principle of filter. The second one is score. The third one is bind. Okay, so right now we have two worker node, worker 1, worker 2. Let's take example. We have one more worker node, worker 3, and we have requested to create the pod. Okay, in the time of filter, what it is going to do, it will check worker node 2, worker node 3. It is going to check the memory utilization, the CPU utilization, and the other component which is called as affinity tools. Right now we are good to ignore it. We are going to have a detailed discussion what is called affinity, taint, toleration and all. But whenever scheduler is going to filter on the available worker node, it will check the memory, CPU, affinity and the other component. Okay. Then I would say it will select one of the worker node. Here I would say the worker node 3 is highly utilized, so it will be rejected. What it will have? It will have worker node 1 or worker node 2. So here comes very interesting question. Where scheduler is getting an information regarding the memory utilization, CPU utilization or affinity. So to fetch this kind of information, we have one component in master node called as ETs. Okay, let me draw. So to fetch the information regarding the worker node, scheduler is going to send a request to our API server, and then our API server is going to interact to another component called as ET. Okay, what is etcd? Etcd is a database which has the all information regarding our Kubernetes cluster. So in terms of our decision making, which I have mentioned, scheduler work on three principles. One, firstly, it is going to filter, then it is going to score, and then it is going to bind. Till now, we have only discussed about the filter, like we have three worker node 1, worker node 2, worker node 3. And what I have mentioned, the worker node 3 has high CPU and memory utilization. So how scheduler is going to know, like, okay, this worker node has high CPU and memory utilization. It is going to send a request to our API server, Then API server is going to send a request to our etcd. Etcd has the Kubernetes database which has the information regarding our Kubernetes cluster. It will send the information, and then according to the information, whatever the database has sent to our API server, scheduler is going to do the filter among the worker node. Okay. So we discussed about the filter process. So we have the two worker node available, worker node 1 and worker node 2. In worker node 1 and worker node 2, again it is going to check on the principle of capacity or node proximity. Then finally it is going to select one of the worker node to create our pod. So this is the basic process of our scheduler. Okay, and then finally it is going to say like, okay, we are good to create our pod in this worker node name called as worker node 1. Okay, let me go to the diagram again. So finally what we have done, we have selected worker node 1 to create our pod. So in each worker node, the point of contact is called as kubelet. Okay, in worker node 1 also, in worker node 2 also. Called as kubelet, and it is going to connect to our API server. Okay, so in this process, what we have done, we have requested for our pod creation. The first stage, it has gone to our API server. API server has sent a request to our controller, like, okay, who is going to do the work for me? I would say we have the pod controller who is going to create a pod for me. This, then it is going to update our API server. Then the API server is going to connect to our scheduler where we need to create our pod. So this will be our fourth request. Then the scheduler is going to connect to our API server again to have the information regarding filter, score, and bond. So it is going to send a request to our API server. Then API server is going to interact to our etcd. Then etcd is going to send a request to our API server. Then again the API server is going to update to our scheduler. Okay, scheduler, and then scheduler is going to give a final result. Okay, according to my filter, score, and bind principle, we are good to create a pod in this worker node called worker node 1. Then our worker API server is going to interact to our kubelet. Okay, and then in our kubelet have one component which is called as CR. This is called as CR. And CRE, the full form of CRE is, I would say, this one is called as container runtime. Okay, this container runtime interface is basically responsible to create our containers. And then finally, the CRE is going to create a pod. And inside this pod, what we are going to have? We are going to have, I would say, two containers. Right now we have requested for two containers. It will create a container 1 and it's going to create a container 2. Okay, and we have one more component which is generally responsible for kube-proxy. Okay, and kube-proxy is generally responsible for our networking configuration. In each and every worker node, you're good to have one kubelet that would be the point of contact to our API server, and then we are good to have one kube-proxy that is going to be interconnected with each other. So this is the diagram which represents the Kubernetes architecture. Okay, I have created one more diagram using Lucid chart. So let me open it. If you see in this diagram, again from the kubectl command or from the graphical user interface, what we are going to do, we are going to send a request to create the pod. So the first request is going to interact to our API server. Then our API server is going to send a request to controller, and controller is a person, as we have discussed, is going to do the selection who is going to the work. So we have the pod controller. So the pod controller is going to create a pod for me. This thing, it would be updated to our API server. Then API server is going to interact our scheduler, which is responsible to select the worker node, means where we are going to create our pod. So then to fetch the information, to filter, score and find, it is going to send a request to our API server. Then our API server is going to send a request to our etcd. Etcd is what? Etcd is our database configuration of Kubernetes cluster, which has the total information of our Kubernetes. Then this etcd is going to send a request to our API server. Then again, our API server is going to update about each and every worker node. Then finally, on the basis of the information which we have provided from our etcd, it is going to select one of the worker node. I would say it is going to select worker node 1. Okay. Then this worker node 1 result will be updated to our API server. Then it is going to connect to my worker node 1. I would say this is my worker node 1 and this is my worker node 2. Okay. So in step 10, it is going to connect to my kubelet, and then my kubelet is going to connect to my container runtime interface. And finally, the container runtime interface is going to create what? To create our pod. And inside the pod, we have the 2 containers. And finally, once my pod has been created, with the same process, it is going to update our API server. And finally, the API server is going to update our database configuration. So this is the whole architecture of Kubernetes, from the user end to master node to worker node. Okay. So with this, we have completed our Kubernetes architecture. So thanks a lot for watching the video.